Now, one thing I truly did not appreciate about organometallic complexes when I started teaching organic chemistry, because I'd worked with them for my graduate work, but I'd never used them for organic synthesis. They were used for something else, was their utility as nucleophiles. And there's two major things about them being nucleophiles that kind of gets left out of your textbooks, in my opinion. The first is that because we are forming a carbanion, there's no rearrangement here. So in terms of making carbon-carbon coupling bonds, unlike a carbocation where we're using a nucleophile to take the carbon, we don't have to worry about rearrangements. We don't really have to worry about our solvents and ending up with a lot of rearrangement products. The second is that this is a carbon coupling reaction, and these are incredibly difficult things to do. It's hard to really make carbon bond to carbon because typically carbon's bound to other things that don't want to give up their bonds. So when we talk about organometallic complexes, the big reason why we want to make organometallic complexes is we want to do carbon-carbon coupling reactions. We want to attach one carbon to another carbon. And the choice of the organometallic we use, organolithiums, grignards, organocuprates, these are going to be set more by the locations, whether we want to do a primary, secondary, or a tertiary carbon that we're going to attach, and also kind of based on the reagents we have at hand. So while we are going to talk very much about how to make these organometallics and we're going to discuss reactions, understand that this is kind of the big picture. We like organometallics in the context of organic chemistry because they are carbon-carbon coupling reactions. Now, a few other comments that kind of get lost in the details. A ligand and an organometallic complex are not quite the same thing. So typically when we talk about organometallic complexes in organic chemistry, particularly in your textbook, the details tend to focus on things that are carbanions. So again, this is what a grignard is, this is what an organolithium or organocuprate is. Organometallic complexes are actually a big, broad umbrella, and the organometallic complexes that form carbanions are just one subset. Another, honestly, far more useful and far more interesting subset are organometallic catalysts. So things like the vitamins in your body, the B vitamins, there is a big organic thing wrapped around usually a single transition metal. So how are these different than the organometallic complexes we're talking about in organic chemistry? Well, the thing is, typically when we have organometallic complexes, we're more referring to catalysts. So big example of this, Ziegler-Natta catalyst, is titanium with two cyclopentadienyl rings attached to it. And the reason I'm drawing like this is that when we're talking about organometallic chemistry in organic chemistry, particularly with this course, we're focusing more on the reactions that the organics do with other organics. Well, the Ziegler-Natta catalyst, the organics here do not actually participate directly in the reaction. What ends up happening is that we run ethylene over the titanium catalyst, and what we pop out is polyethylene. All the chemistry is taking place around the titanium atom. The titanium atom is doing all the work. The organic parts here, the ligands, are actually tuning the titanium's reactivity so that it binds the ethylene, but also allows the ethylene to continue to bind to other ethylene units. So again, we're going to talk about organometallic complexes, focusing mostly on ones that are being used for carbon coupling. The bigger, more relevant one here, organometallic catalyst. These are a huge field. A lot of them have won Nobel Prizes for the work they do, but those are kind of outside the scope of this course. So let's take that and let's start working our way through the organometallic complexes and those types of reactions.